This is a production of Cornell University.
Hi, everybody. I'm Josh Randall. I'm the Natural Resources Educator at Cornell Cooperative Extension, Niagara County. I'm going to talk specifically about weatherization of homes and then what that looks like in terms of saving energy, reducing greenhouse gases, and protecting health. But I also serve as a clean energy advisor with the Western New York Clean Energy Hub. So I have responsibilities that, I guess, transcend that and are really focused on residential opportunities in general. So if you have thoughts on that, I will have a table tomorrow at our Energy Expo, which you're all definitely invited to come to, and we can talk more about some of those residential opportunities. Oop, is it not clicking? Okay. So I know that Jenny actually covered a few of these terms, but I always like to try to make sure everybody's on the same page when we have these kinds of conversations. So just going through really quickly, the idea that we're going to talk about here is in the background. These are some of the ideas that we should have when we're thinking about these things. So climate change, these are just long-term changes to stability or predictability of weather. Sustainability is the use of resources without endangering our future generations' availability. Resiliency is ability for a system or an individual to bounce back from unexpected changes. Environmental justice is equitable distribution of environmental resources and contaminants. And decarbonizing is the reduction of the amount or intensity of greenhouse gases released by a process, a building, any kind of thing. But most importantly, the thing that I'm going to talk to you about today is weatherization. And so what is weatherization? Jenny gave a very brief explanation of this, but I like pictures. So I have a diagram for you guys to think about. So let's imagine we have a very basic house. There's a door, there's a window, there's a roof. And if you even note, there's actually ways, I'm not tall enough, to be able to see how there's actually air moving up into that roof through those little openings there. And so what's really, really important to think about then is that every single place where you have a hole in the house, that's a place for air to move in or out. So that means in the summer, you're losing your AC, and in the winter, you're losing your heat. And also, more importantly, the real risk to people that we'll talk about later is that means that any outdoor air pollution immediately becomes indoor air pollution. And so what do we do about that? Well, we weatherize. So that can look like a few different things. So, the really biggest priorities are actually going to be focused on the top of the house. So this could be something like adding bats of insulation or adding baffles to be able to control where air is flowing. It could mean adding additional insulation in the walls and rim joists. It could mean adding door sweeps or adding additional air sealing along the bottoms of windows. So there's a lot of different places that we can try to prioritize, but we should really be thinking about this as a whole system. And especially since we're thinking about things as whole systems, we can then try to think about how this might affect other kinds of systems. And that's why I'm going to start talking to you a little bit about health, energy, economics, and environmental outcomes of weatherization. A little bit of historical background. This is Jenny's favorite figure. She loves to show this, but this is actually really, a really great breakdown of what's going on in New York State right now. As we know, buildings and transportation are the biggest components of our greenhouse gas inventory. However, if you make a quick note, actually the green is also energy. And that means that energy has to also be a part of that transportation and building components. That really means that we're really thinking about in people's individual day-to-day lives, more than 50% of the greenhouse gas emissions are coming from. So we can't exclusively think about this as being a problem that our large corporations and businesses have to deal with. It's something that we have to be able to take on as a society. And so as a result, the Climate Leadership and Community Protection Act was passed in 2019 by New York State, and it resulted in the creation of a scoping plan. And that was really some really big requests. And specifically, they wanted to see that we could have 85% of greenhouse gases reduced by 2050. And that could look like a lot of different things. And especially one of the things that they mentioned directly in that scoping plan is that 1 to 2 million households across New York State are really going to actually need to be electrified with heat pumps by 2030 to be able to reach our goals. So that means that we really need to be thinking about this in terms of how are people in this room, in our communities, across the state going to actually be able to meet these goals, weatherize their homes, and actually be able to achieve electrification. And most importantly, we also have to think about this in the lens of a just transition. New York State explicitly states this in the scoping plan that we must ensure that disadvantaged communities receive at least 35% of all of the benefits that New York State produces through their expenses on this sort of work. And really, I think this is one of the more important things is that disadvantaged communities is a very broad term that New York State actually uses. And it includes things places like low and moderate income people and areas, as well as communities that had land use associated with historical discrimination or disinvestment. And that's like a really big phrase, but really what that means is that people and places that were a part of the way that we developed the state have to be able to be the ones that actually get the benefits from us further developing the state. This is a picture of Western New York because that's where I work. And these are actually in blue, all of the places that New York State considers to be disadvantaged communities. And the thing I want to highlight is that essentially the entire city of Buffalo, the city of Niagara Falls, the city of Lockport are all considered disadvantaged, but so is the Tuscarora Nation, the Cattaraugus Nation, and the Tonawanda reservation. And so what we really have here is some of the areas we would normally think about, but even more interestingly, you see a lot of ag land is also considered to be a disadvantaged community. And that's why we have to think about this as not just the people that, normally get considered in these conversations, but it's a much bigger pool of people that have to be involved in the decision making. And like I said before, this means that the communities that became disadvantaged as a result of the externalized costs of development have to be a part of the modern development as a part of the remedy. So the groups, the people, the places that actually received the sort of disadvantaged nature because of disinvestment or discrimination have to be the ones to see the 35% of the benefits. Okay, so now I'm going to talk about energy. This is a really important map right there on the right. That's actually New York State. It's from Energy Star. So that's how they kind of think about how much insulation people need. That's sort of like the bare minimum idea. So they group the state into a bunch of different areas. And so really what that means is that there's going to be diversity across the state in terms of what people actually need. But still, 90% of all homes in the United States are considered under insulated. And especially, like I said, we have a diversity of insulation needs, but almost everybody in New York State is expected to need R60 in their attics and R14 in walls. That R stands for resistance value, and so it tells you how much the insulation is able to resist the movement of energy through it. And so the higher the number, either the thicker the insulation has to be, or the less conductive that material would have to be. So what that really means is that people are not seeing the insulation that they need when they constructed the house, when they've done insulation in the past. And that really requires then that we take it a little bit more seriously and actually work to make sure that insulation is happening. And especially, it becomes even worse when we consider that most attics only ever have floors insulated and never the actual ceilings. And crawl spaces and rim joists are considered dangerously uninsulated in most places, as well as the fact that New York State actually worked to try to remedy some of this with their stretch energy code in 2020, but municipalities have to individually approve that in order for that to actually function where they live. So we actually have a number of problems that are actually made worse because we also have an asbestos insulation crisis, and because some homes will never be able to have wall insulation if you have slat walls in a wooden home. So saving energy is a very difficult thing for a lot of parts of the state. And it also comes down to a thing about who's even really focusing on this. I'm really thinking that this saving energy conversation really leads well into a larger conversation about behavioral change. Ken gave a really great talk there about what it looked like to have that behavioral change in a specific industry, but we have to potentially be thinking about this across all industries and all communities. So we turn out the light. Who actually cares about saving energy? Well, there's a few people that should think about it the most. People that want to see the immediate financial benefits for their household, people that want to see a more efficient grid, and people that want to prolong the mechanical and electrical equipment in their household. Your furnace, your hot water heater, all of those things do better the less intensely you use them. And so we really have to think about energy saving as being part of these normal behaviors that people already care about. We also know that utilities are already seeking rate increases across New York State because energy use continues to increase across all times of day and all seasons, in part because of some industries increasing their use, but also in part because New York State continues to develop and expand. And we also know that, like I said, buildings are the largest category of emissions, and space heating is the largest proportion of that building emission. So if you care about climate change, or if you care about financial benefits for households, you must care about building decarbonization. That did not fix itself. So these were a couple of other figures I wanted to make sure I threw in here that kind of talk a little bit about why energy saving is so important in New York State especially. So on the left, that's actually from the New York State Comptroller, I'm sorry. And that actually represents the percentage of customers that are considered to be in arrears by utility across New York State. And you can see even the minimum, which is National Grid and Long Island, at least 8% of all the customers are considered to be arrears in 2022. So that's 2 years after COVID. We have a huge number of people that are in financial straits because of the fact that they can't afford their energy. And it actually gets worse when you consider that on the right, that's from EIA, that is the number in billions of dollars of rate increases across the United States, across all the utilities. So we're seeing utilities are increasing their rates. People already can't afford them. And what are they actually going to do? They're going to have to look towards weatherization. Okay, I'm going to talk a little about greenhouse gases now to switch it up. At the bottom there, that's actually, I think, a really interesting figure so people can kind of get an idea of how this stuff works. And I'll talk about it in a little bit. But normally I'm trying to think about this in terms of weatherization, but a lot of this also kind of leads into electrification. And especially that's where we see the most benefits for greenhouse gases. And so as we try to weatherize, we have to realize that a lot of this is going to be in preparation for that. But just weatherization on its own is actually able to reduce the total US emissions by 5%. It's actually 4.7 exactly. But so just insulating homes across the US is a massive reduction in our total greenhouse gas inventory. But we can also then shift people better towards heat pumps because we can actually be realistic with what people actually need with terms like right sizing. And that's what that figure in the bottom there. So that's considered to be approach number 4. So this would be what you would consider how you would design a heat pump in upstate New York. So what that really is saying is we can try to make sure that the heat pump is able to work at even low temperatures without wasting too much energy at higher temperatures. And so you can actually do this better if you've already done the installation, if you've already done the energy assessments. And so we have to think about this in advance. And then, like I said, too, like we have to think about how this also relates to a lot of our other movements we're having. We know that refrigeration is actually rapidly changing in New York State and across the United States as we start to phase out the worst refrigerants. But that's going to be a process that's going to happen over and over again. But it especially is related to this because we know that HVAC units are some of the ones that contain those most harmful greenhouse gases in abundance, and that whenever they get repairs, they get off-gassed. So we have to be ready to be able to do the weatherization, to be prepared for the electrification, but also know that that's also a part of a bigger scheme of how greenhouse gases are going to be reduced. These are another couple of really interesting figures, and I'll talk a little about them as I go along. What we also know is that as we're reducing greenhouse gases, people are going to have tighter home envelopes, and that means that they're going to need to rely less on ACs, which are already considered to be grid heavy. As you can see, the expectation on that bottom right figure is that New York State, and that's actually from the New York Independent Service Operator, the New York State as a whole is going to be moving from a summer peaking system to a winter peaking system by 2037. What that means is that as a whole, we're no longer going to see our most energy use in the summer. We're going to see it in the winter. Most of that is believed because we're going to be shifting towards electric forms of heating, but it's also hopefully going to be because people are able to actually do the weatherization work and not have to waste as much energy on air conditioning. And it I can't promise this, it should also reduce dangerous and wasteful forms of heating and cooling, like leaving your oven open or leaving your refrigerator door open. People die every single year from doing this, and that's a completely avoidable death just through the use of weatherization technology. It also is going to mean that we could potentially even out demand, which means we might be able to actually phase out the peaker plants, which we were not able to do in this next year. So that's what that top right map is. That's where all the peaker plants are in New York State. What that means is that when the grid hits peak load, they have to turn on additional power plants. And you can see right there in the middle of New York State, that giant gray blob, that's a giant oil plant. So a lot of upstate is still reliant on that. And if you go down to downstate, a lot of that's all natural gas and then a couple of pretty large oil plants. We're still very reliant on fossil fuels every time we hit those really intense parts of the summer because people need that AC. The last thing I wanted to talk about is protecting health. And this is something I try to really be the most forward with when I'm talking with people in my day-to-day work, because I think this is the thing that people forget the most about. Like I said, Ken did a really great job talking about how this works in terms of landscaping industry, but we know that these are health concerns related to fossil fuels, related to the ways that we've designed our society across the board. So I'm going to give a quick overview. One of these things is going to be indoor air quality. Like I said, outdoor air quality is the greatest predictor of what indoor air quality is going to be. If we can reduce fossil fuel use, we're going to see better indoor air quality. But more importantly, we can do things, like I said, reduce air coming in. We can also reduce mold growth. So we know that a large percentage of the mold that's happening in people's homes is because of under insulation in attics. We also know that radon and rodent feces are coming up through people's crawl spaces because those are also under insulated. The next thing that we can think about is ensuring that the efficiency of our mechanical and electrical equipment systems is going to be able to maintain themselves longer. And the reason why that's important is because our equipment increases carbon monoxide production as they age. And so especially if you're in areas where you might have your furnace, your hot water heater in an area where you might be having it on the same floor as where people are staying, that's a real danger to people as they age. It also means we can maintain higher water temperatures and reduce our Legionnaire's risk. We've had people in the last year die in Albany because of Legionnaire's, and likely it's because we were not able to keep that water temperature at the prerequisite level, and it was allowed to then grow uncontrolled. We can also then produce less thermal pollution. We can make sure that we're not going to be increasing heat island effects in cities by having all these buildings always outputting all this excess heat in the winter. And we can reduce pest entrance to the home. We can try to reduce the number of rats and stink bugs and flies coming into people's homes just by air sealing. And the most important thing, and the reason why Buffalo cares about this, is we can make sure that there's more hours of safety during extreme weather. We lost people in 2022, and those were also avoidable deaths just by increasing weatherization. So that's what I had to have. And that's all I have. So yeah, and I know we're not doing questions now. So thank you.
Thank you.
This has been a production of Cornell University, on the web at cornell.edu.